Mostly what we're talking about today is called percent change. And there is a little formula. Actually, we're going to use this formula over and over again in this chapter. So if you want to maybe write a note down somewhere, this is a pretty big deal for this chapter. Percent change. Actually, before I write the formula, what if there were 100 students, and then in the high school or something, and then if our numbers increase to 150, what percent increase is that?
50, sorry.
No. Yeah. 50. It is 50%. Why is it 50%? It increased by 50 out of the 100, yeah, which is half of what it was. It increased by half of what it was.
So, yeah.
Okay, that's a 50% increase. If I go from 100 to 50, dropping by 50, that's a 50% decrease. Okay, yeah, that's a big drop. Percent change. So it's not like a grade on the test. That's a percent that we're getting bigger or that we're getting smaller or whatever. Percent change, the formula is you do the change divided by the original. So what was the change on this problem? 50. What was the original? 100, the starting one. So what's 50 divided by 100? If you plug 50 divided by 100, I know this looks like a fraction bar, but this is a division bar, okay? Same thing, kind of. What is 50 divided by 100 if I put it in the calculator? 0.5. And how did we change that to a percent yesterday? Decimal twice. Now I know you guys know that's 50%, but a lot of these answers are going to be messier than that, right? That was just my So, yeah, we're going to be using this a lot. This is not everything we're learning today, but this is kind of the foundation for today. Let me go turn this computer on.
LOL, stretches of distribution are named after coconut or coconut. You start coconut balls. Stop it. Stop. It just says
All right. Are you guys ready? Did everybody write Simon down already?
Yes.
Okay, page 119. Number 1. All right. Okay, it says find the percent change. So do you guys remember what to do?
Divide.
Change divided by original. So what is, on number 1, what is the change?
100.
No, 20.
80.
Change is 20. What's the original?
80.
80. What is 20 divided by 80?
40.
And
0.25.
what you guys are thinking is 80 divided by 20 is 4.
It's 0.25, right?
20 divided by 80 is not 4, it's 1/4 or 0.25. Okay, but the question is what's the percent change? So we got 25%.
LOL. Stop.
So it's getting bigger from, why is it a 25% increase? Because 20, listen, because 20 is 1/4 of 80, right? It takes 4 20s to make 80. 20 is 1/4 of 80, or you could say 20 is 25% of 80. Since we increased 80 by 20, we increased 80 by 25%. Does that make sense? We went from 80 to 100, so we increased 80 by 20. 20 is 25% of 80. So that's how much we increased the 80 by. 25% of itself. Okay. Hopefully it kind of makes sense. If it makes sense, it's a lot easier to remember it than if you just kind of do it over and over again. Okay, number 3. So back to the formula. What's the change on number 3?
390.
390. If you do 450 minus 60, by the way, it doesn't matter if you're going from big to a smaller number or smaller number to a bigger number. You always do the big one minus the small one to find the change. The formula works both ways. 390 is the change. What was the original on this problem?
60.
60.
LOL.
Okay, what's 390 divided by 60? 6.5. What is 6.5 as a percent? 650%. So basically, what we're saying is that 450 is like 6.5 times bigger than 60. Actually, it's 7.5 times. Yeah. Oops. Yeah, I'll talk about that in a second. Okay, number 5. This is a little bit new. Actually, you might have seen it last year, but you probably forgot if you did. Okay, so actually, I'm going to ask you guys, what do you think? We're trying to increase 700 by 40%.
700 times 0.40.
Okay, she said 700 times 0.40 or 0.4. That's going to be 280. If I increase 700 by 40%, should it go to 280?
No.
Should be bigger, right?
Divided up. You were wrong.
No.
Stop. You didn't even try.
No, she was on the right track.
Is it still wrong?
Okay.
Still.
So what she did was she found out what 40% of 700 was, 280, almost half of 700. But that's the amount that we need to increase it by. We need to increase it by 40%, so we need to increase it by 280. So it's 700 plus 280. 980. Okay. This concept, the percent change is, well, percent is used all over the place, but percent change is used a lot in real life. Almost anything to do with, like, the population of Bartlesville increased by 1%, or the price of the car dropped by 10%, or, you know, there's just like, we use these all the time. Percent change things in real life. Or like if you see a sale at Walmart, it's like 30% off or whatever. 30% off, that's a percent change. It's a 30% lower than it used to be. Anyway, yeah. So on number 7, we're trying to decrease. So this one says decrease, that's important. 600 by 55%. If I'm going to drop it by 55%, is it going to be more or less than half of what it is now? Right. If I'm dropping by 55%, I'm taking most of it away. So my answer should be smaller than 300. Because I'm taking away most of it. Okay, what do? There's 2 steps. Multiply. 600 times. Right. What's 55% of 600? I think it's 330.
Yeah, that's what I got.
Okay. Does it drop down to 330? No. 330 is what it's dropping down by. Like, this is how much it's going to drop. The change. Yeah. 600 minus 330 is 270. Okay. Now I'm about to go in hard mode here.
Oh, no.
I want to try to explain something. Okay. There's actually 2 ways to do these problems. I just backed up to number 5 here. Okay. Question 1. What is 100% of 700? What is 100% of 700? 700. You're like, is this a trick question? 100% of 700 is 700. If I increase that by 40%, I want 140%. If I want to increase 700 by 40%, then really what I want to do is figure out what 140% of 700 is. Does that make sense? right now, this is at 100%. If I'm going to increase by 40%, 100 plus 40 is 140%. So another way we could have done this problem is 140% of 700, or in other words, 1.4 times 700. Guess what that gives us? The same answer. Okay. Now on the decrease side, same idea. If I want to drop 600 by 55%, this is 100% of 600. So if I want to lose 55%, then what percent should I have remaining?
1.5. No.
If I want to lose 55%,
45.
45% should be remaining. So what I want is 45% of 600. And guess what that gives us? This thing right here. It's another way to do it. It's actually a little faster, but it's slightly harder to understand because the percents thing, I guess. But we kind of need to understand it a little bit to do the last two problems. So I'm not going to do it this way because we kind of have to. It's useful to know just the change sometimes, like just the 330 number. So I'm gonna do it the first way we learned it. So basically all I did was I added, if it was an increase, I added the percent. If it was a decrease, I subtracted the percent from 100. 100 minus 55 is 45. What's 45% of 600? That's it. Anyways, I'm gonna kind of forget I said that for a while and go back to what I was doing. Number 9, I want to increase 600 by 105%. If, hold on, before we do this, if I increase 600 by 100%, what would that?
1.5. Or is it just 600?
Would that be 1,200?
Or 600?
No.
I have no idea.
Maybe.
Yeah.
Yeah.
Well, what's 100% of 600?
600.
So if I increase by 100%, I'm doubling it, right?
Yeah.
So if you increase by 100%, you're doubling it. If you increase by 200%, you're actually tripling it, because there's basically 3 of them, and so on. If you increase by 300%, that's 4 times as much. So it's kind of weird. It's a little bit off how you might think of it. Okay, tell me what to do.
600 times 1.05.
And 630.
Plus.
Right. This said increase, so make sure you read carefully. Some of them say decrease. They jump back and forth.
1,000.
1230.
1,230.
Yeah. If it increased by 100%, it would be 1,200. So this is a little more than 1,200, so that makes sense. Okay, we are jumping to 15. Okay. This will be challenging, especially towards the end. Remember I said the last two? The reason it's challenging is because every 2 problems, they do something a little bit different. If, like, you see how they left different blanks? On 15 and 16 have the same blanks, and then 17 and 18 have the same blanks. So you have to do something a little different every couple problems. It is challenging. It kind of starts a little easier and then kind of works its way to hard. I told the other class, like the last 4 problems are the hard ones. If I do put that on the test, it'll probably be a bonus. But the rest of the stuff you are responsible for, basically. Okay, number 15. You don't have to write the table. It's just fill in the blank. So 68 is the original amount, and we're supposed to add 15. So how do I find the percent change?
Change over original.
Back to the formula. Change divided by original. What's the change on 15? 15. They just told us this time. Remember on 1 and 2, well, 1 and 3, we had to find the change ourselves, but this one they're just telling us. The change is 15. What's the original?
68.
Okay. I didn't read the directions. The directions say round percent change to the nearest tenth of a percent. What's the tenth place?
First place?
First decimal place.
Oh.
Okay, that's basically the only directions they give us. So the other numbers are like normal numbers, so only that percent are we gonna round. Anyway, what's 15 divided by 68? Point, keep going, 2, 2.
0, 5,
Okay.
8, 8.
We actually only need that much, because what's this as a percent?
22.
22. Remember, we want a
0.1.
0.1,
Yes.
because that's a tenth of a percent. So that's answer 1, first blank. Okay, the second question on 15 is what's the new amount? If we started with 68, the change is supposed to be plus 15.
83.
Yeah, you just add those together. So the new amount is 83. Any questions on how we got that?
No.
Did we need the percent change to figure that out? No, we didn't. It's kind of like just a separate idea. Okay. Make sure you take good notes on these because 15 and 16 are the same, 17 and 18 are the same. Just kind of got to repeat the process. 17, it says the change is plus 20 and the new amount is 135.
So it's 150.
So how do I know what the original amount was? Right, if we added 20 to get 135, then we work backwards by subtracting 20. It's kind of like yeah, it's like an algebra equation, right? It's like this. Subtract 20 is 115. Is the original amount? Whoa.
And then we do 115 divided by 32.
Not quite. Okay, percent change is, back to this. What's the change?
120.
What's the original? Yeah, the number we just found. And what's that come out to?
Okay, 5.7. 5.7.
No.
1.1.
Okay. If you're dividing a small number by big, it's in the order that it's written. 20 divided by 115. 20 divided by 115. If you have a small number divided by a big number, you should get a small decimal. Sorry, say it again, Hope. Hope. Say again.
0.1739.
Okay, and then what's that as a percent? Whoa.
Oh, 17.39.
17.4. Okay, I might be a little meaner on this if you don't follow the directions on rounding. So let's do what the book tells us to on this one. Whoa. That was good. Okay, number 19. It says the original is 125, the new is 86. 125 and way over here is 86. So how do I figure out the change from 125 to 86?
I mean, it got smaller.
Subtract, right? It's getting smaller. How much smaller is it getting?
86.
I mean,
No, 86 is what it
Oh,
ends up at.
like,
so you subtract
31.
You subtract?
Yeah, 125 by. No, you subtract 86 from 125, right?
Okay, yeah, it went down 39. So the book would have written subtract 39. I'm going to be a little bit lazy and write minus 39. That's the change. Really, the change is 39, but I'm just showing that it's going down instead of up. Okay, I'm not going to plug negative into my formula, by the way. It's either going to be like a 20% increase, 20% decrease. I'm not going to call it negative 20%, whatever. 39 over 125 is the percent change. What does that come out to?
0.312.
.312, what?
Oh, I got nothing after that.
Oh, that's it?
Yeah.
So, okay, what's that as a percent?
41.2%.
31.2, I kind of forgot to,
Oh, I wrote that down on the wrong one.
okay, so both of these are the answers, I kind of forgot the first part. 39 is the change, a decrease, and that's 31.2%. Okay, let me talk about this problem for a second. What's the relationship between 39 and 125? It's about 30, this number is about 30% of this number. So it's about a third of that. That's what this is saying. You guys know what a third is as a percent? 33.3 repeating.
Yeah.
If you do 1 divided by 3 in your calculator, you get .33333 forever. Anyway, that's what this means. This number is this percent of that number. But we don't subtract this number, we just subtract this number. Alright, anyways. Okay, 21. Getting close, 3 more. 274, and we're supposed to increase it by 53%. Okay, this is just like number 5, 7, and 9, those problems.
274 times 0.53.
Right. First, we need to figure out what 53% of 274 is. Say again? 145.22. Is it going up that amount or is it going down that amount? How do you know it's up?
Increase.
Yeah, because it said 53% increase. So my first answer I'm going to put is it's going up 145.22. That's answer 1. That's the change, right? Now that we have the change, how do I find the new amount?
You add it.
Yeah.
Answer plus 145.2.
Yeah, the original plus is supposed to go up this much. So that plus that equals 419.22.
It sounds cool to say 2-2.
Any questions on that one? Okay. This is where I said these last 4 are bonus territory, okay? So let me describe it and then maybe one day we'll get a bonus on the test for this. So it says it's missing the first 2 blanks, but we're supposed to do a 75% decrease and end up with 350. Okay, I'm going to call original X. I don't know what it is yet. If I'm supposed to drop that by 75%, then how much of that number should be left? If I'm supposed to drop this number by 75%, what percent is left? Not 15, 25%. So 25% of the original number is going to give me the new number. If I'm taking this down by 75%, then 25% of the original is going to give me the new amount, which was 350. So that's how you do it. And then a little bit of algebra skill here. What do we do for
And
X?
this, you divide
By,
0.25.
I'll let our calculator do the heavy lifting. 1400. Why is this number bigger?
Because divide by this.
Yeah, well, we're supposed to drop the original amount by 75%, so the original amount is actually much bigger than the new amount. Okay, that was the hard part. The easier part is going to be the second part, which is find the change.
1400 times 3.
Nope.
Times
So this was the original,
Stop.
this was the new amount right there. So how much did it change? Not percent change, they told us that. How much is it changing from there to there?
Minus them?
It's going to, yes, subtract, yes.
1,050.
1,050, and it's going down 1,000. It's going down 1,050, right? So I'm gonna put minus 1,050. Okay. I am going to help you set up 24, but the first step is the hard step. The second part is not that hard. But let's talk about setting up 24. So on 24 it says we're supposed to increase some number by 150% and get 48. So if I'm increasing a number by 150%, then what percent should I be up to? Big percent. Okay, right now this number x, I'm going to call the original number x again. Right now it's at 100%. I want to increase it by 150%. So what percent of this number am I going to get? 250. But how am I going to write 250%? 2.5. So 2.5 times the original number should give us the new number, which was 48. Okay, I'm going to stop there. X stands for the original number, the first blank. Okay, that's the hard part right there. All right, 25. I'm not going to give you time to work on it.
So did you do 48 divided by it, or 2.5 divided by it?
Just do normal algebra stuff. All right, 25. Probably the hardest, the last two. All right, all they tell us is that the change is minus 25, and that's 2%. That's a 2% decrease. Okay, so here's what this means. 25 must have been 2% of this number, whatever the original was. I'll call it x again. So, did you hear what I just said? Use the tricks we used yesterday. 25, I said must be, is, 25 is 2% of this number. So 25 is
25 equals
2%. 2% of,
or
okay, that's it.
I know the answer, trust me.
Okay, if 25 is only 2% of this number, should this number be really big or really small?
Really big.
Really big.
So it's like
This number is only 2%, small percent of this number. So this number should be a lot bigger.
1,000.
Somebody already plugged it in the calculator, it's not
1250.
1250. Okay, that's the hard part. The next part is not the hard part. So what is the next part? We're supposed to find the new amount. So the original amount was 1250. What are we supposed to do to that? Take away 25. So what's the new amount going to be?
1225.
1225. Okay, so I'm going to do the same thing. On 26, you guys get that?
Yeah.
On 26, I'll help you with the first step again. Second step should be easy. Okay, so on 26, they're saying 0.3 is a 125% of the original number, basically is what they're saying there. 0.3 is
Equals
125% of the original. I'll call X the original again. Okay, so solve that for X. What's being divided by what? This is a problem that a lot of people would probably divide backwards. You're dividing by 1.25, right?
2.
Not by 0.3.
Yeah.
And don't forget to find the new amount. Alright, try the evens. You know what? I don't know if that was on the screen. Darn it.
Yo,